Good day, everyone. My name is Ryan Jordan Yames from Basic Science Section 13. This is our class report assignment from the topic The Forces Within about Divergent Boundaries. I am assigned for oceanic ridges and seafloor spreading, while Meika Manikani, my groupmate, is in charge for continental rifting. When we discuss this report, I hope you guys enjoy watching and learn something out of it. Before we begin, let's read first the objective of this lesson. First, what is oceanic ridges and seafloor spreading? Second, discuss how seafloor spreading affects the continent. Lastly, describe how seafloor spreading works. To learn more about this topic, let's first understand the history behind it. Let us start first with Alfred Wegener. In 1912, Alfred Wegener came up with a theory called continental drift. This is the idea that continents have been shifting positions over time. He saw that the continents seemed to fit like a puzzle and once joined into a single landmass called Pangaea. This theory also explained why the same animal and plant fossils are found in different continents. However, there is no proof how the continents moves apart. Then his theory firmly rejected. But later, in 1912, a geologist and a Navy submarine commander, Henry Hess, proved Wegener that he was right. Part of his mission was to study the deepest parts of the ocean floor. In 1946, he discovered that the hundreds of flat-top mountains, or perhaps sunken islands, shaped the Pacific floor. Later, in 1960, after much thought, he concluded that the movement of the continent was the result of the seafloor spreading. So what is seafloor spreading? Seafloor spreading is the process in which two sections of the seafloor spread away from one another. This occurs through the movement and shifting of the tectonic plates under the ocean because of the result of the mantle convection, which carries heat from the lower mantle and core to the lithosphere. We also need to know that majority, but not all, divergent boundaries are associated with oceanic ridges, which is elevated areas of the seafloor characterized by high heat flow and volcanism. The global ridge system can be said as the longest topographic feature on Earth's surface, exceeding 70,000 kilometers in length. It also represents the 20% of Earth's system that wins all major ocean basins like seams on a baseball. In addition, the term ridge may be misleading because it implies narrow, but in fact, ridges vary in width from 1,000 kilometers to more than 4,000 kilometers. Further, along the crest of some ridge segments is a deep canyon-like structure called Rift Valley. This structure is evidence that tensional forces are actively pulling the ocean crest apart at the ridge crest. How to create a new seafloor? The ocean ridge system, together with seafloor spreading, create a new seafloor. As a tectonic plates moves away from each other, magma rises from the asthenosphere, then eventually climbs up to the lithosphere, creating a ridge. The magma then cools and new crust is formed from both sides of the ridge, pushing the seafloor apart. As a new oceanic crust is formed, an oceanic crust is pushed down to a trench and melts into a magma. Typical rates of spreading average are around roughly 5 cm per year, roughly the same rate at which human fingernails grow. Comparatively slow spreading rates are 2 centimeters per year are found along the mid-Atlantic ridge, where areas spreading rates exceeding 15 centimeters per year have been measured along section of the East Pacific rise. Although these rates of seafloor production are slow on a human timescale, they are nevertheless rapid enough to have generated all of Earth's ocean basins within the past 200 million years. The primary reason for the elevated position of the oceanic ridge is that the newly created oceanic lithosphere is hot, which means it is less dense than the ocean or the cooler rocks found away from the ridge axis or the line. Example is the mid-Atlantic ridge that is spreading 5 cm per year is divergent boundary between North America and Eurasia plate in North Atlantica and South America and African plates in South Atlantic, causing the Atlantic to expand into a seafloor spreading. Since the Atlantic is growing and gaining area, another ocean must be losing area. Therefore, the Pacific Ocean will keep shrinking to subduction zone, that is when dense oceanic crust sinks below another crust and therefore destroying seafloor. After all, seafloor spreading, or the process in which new oceanic crust is being created, plays an important role in shifting of continents. Thinking about it, seafloor spreading really affects our lives. Without it, all the continents are still connected, and therefore, there will be no individual continent separated by ocean. Surprisingly, seafloor spreading has been causing continents to move apart over time, meaning that one day the continents will crush each other over again, changing our lives dramatically. That's all, and thank you for watching of my report.
Hello everyone, my name is Mika P. Manicani, BS Ed Science SC13. My topic for today is about the continental rifting. First, the objective. Briefly discuss the continental rifting. To determine what is continental rifting and discuss the function and importance of continental rifting. What is continental rifting? Continental rifting, it is a thinning process of the lithosphere, ultimately leading to the ruptures of the continent and the formation of a mid-oceanic ridges. It is the split of land masses into two or more smaller segments along the continental rift. Another, the continental rifting is an initial and fundamental process by which the separations of two continents into two tectonic plates takes place. Function and importance. The rifting of continental lithosphere is a fundamental process that controls the growth and evolutions of continents and the birth of ocean basins. And ripping a tectonic plates apart elevates the regions and causes earthquakes, volcanic eruptions, and the formations of long mountain ranges separated by the broad valleys or basins. Example, in a given two picture, it is an example as the mantle convex magma rises as a plum from the mantle, causing the continental lithosphere to expand and dome upward, and the uplifted area splits into the three radiating features, forming a triple junction. In a given one picture, it is an example of the East African Rift Valley or Afar Triangle. It is a rifting occurs and the three plates move outward away from the thermal plume. My reference. It came from the 14th edition's Earth Science by Edward J. Tarbach and Frederick K. Lutjens.